In this video, we're going to do some practice examples of factoring by grouping. And so the first two that we see we have four terms, and we're looking at applying this technique. If we have our setup, remember we want to try and pair like terms together so we can factor out GCFs, make sure our parentheses match, we can factor that out, and then write down what remains on the outside. So let's try the first example. We have 15ax minus 10a minus 9x plus 6. So again, all four terms don't have a GCF. I can't do a factoring by trinomial because there's four terms. Can't do difference of squares, so I'm going to try grouping. And the way I'm going to group is I see, I have an A and an A here. 15 and 10 are both multiples of 5, and so I'm going to try pairing these two terms together. 9 and 6 are both multiples of 3, so I'm going to try pairing these terms together. And so if I were to take out my GCF here, 15 and 10, numerically the GCF is 5. AX and A, the GCF is A. And if I look at what would remain in the parentheses, 5 times 3 is 15. I have my A, I need my X. So 3X minus 2. So if I were to factor by grouping right, the next parentheses should be exactly the same. The GCF of negative 9 and 6, you have to be careful here. Some people want to say it's 3, but in actuality, we have to look at this negative sign because we want this first term in the parentheses to be positive, but right now our first term is negative. So what we have to do is we need to factor out that minus sign, and then the GCF of 9 and 6 is 3. So the actual number I'm pulling out is a negative 3. And we'll see when we do this, negative 3 times a positive 3x gives you negative 9x, and negative 3 times a negative 2 gives you a positive 6. So now my parentheses match. If I were to try and factor out a positive 3, I would have the opposite signs in the parentheses, and I would not be able to complete my factoring by grouping. So the key that you need to know here is if you have a minus sign with this term, you're going to factor that out, which changes the signs of the other terms in the parentheses. So I have here, they both have a 3x minus 2 parentheses, so I can factor that out. And what remains is a 5a minus 3. And that is my final answer. We can look at the second example, 2my plus 7m plus 7x plus 2xy. I take a look, I have m's and m, I have an x and an x, so I can try pairing together this way. And I'll try pairing the last set of 2 together. I can factor out of here an m, and my parentheses would be 2y plus 7. If I look at my last set of parentheses, I have 7x plus 2xy. The GCF there is a positive x, so do include the operation. And if I were to factor by grouping right, my parentheses should be exactly the same. But if I look at it, I get 7 plus 2y. And so at this point, some people think, well, your parentheses don't match, something's wrong with your factoring by grouping. But if I were to think about this, if I'm adding two numbers together, 2y and 7, 7 and 2y, if I'm adding two numbers together, doesn't matter the order. If I have 2 plus 7, I get 9. If I have 7 plus 2, do I get a different number? The answer is no. And this is our idea of the commutative property. Addition is commutative. It doesn't matter the order that you add numbers, you're going to get the same result. So what I can do is I have my m, I have my 2y plus 7, and I'm going to rewrite the other one as 2y plus 7. The reason why I rewrote this one is to get it in standard form. The variable comes first, the constant comes last. And now I see they are the exact same parentheses. So I can factor out my 2y plus 7. And I'm left with my m and plus x on the outside. So in these examples, we looked at how to factor by grouping with two terms. We can also factor by grouping, well, by bringing them into two terms when you have four. We can also factor by grouping by using four or more terms. And we have yet to look at the or more terms, and that's where these last couple of examples come in. And so this one we do see we have four terms. However, we see 7mx squared plus 2nx squared minus 7my squared minus 2ny squared. If you look, you see a pattern, 7 and 2, -7 and -2. So I see a pattern repeat, so I can probably group together here. And I also see, these have an x squared in common, so that's a great grouping. I can factor out that as my GCF. And if I do that, I'm left with 7m plus 2n. And remember the warning I gave is if this one is a minus sign, you're going to want to factor out that negative. And so negative, they both have a y squared in common. And your parentheses is a 7m plus 2n. My parentheses match, so I can factor those out. So 7m plus 2n in parentheses. And what's unique is the outside I have is x squared minus y squared. And at this point, most students just write down x squared minus y squared and they go, done, all set. I did a factor by grouping, I used a factor technique, I don't have to do anything else. You always have to make sure you cannot apply any other factoring techniques. I mean, factoring is a continual process. Just because you do one technique, just because I do factoring by grouping, doesn't mean that I stop. This 7m plus 2n, I can't break that down anymore. There's no GCF. You can't do difference of squares. You can't do grouping. You can't do trinomial. I mean, so that's completely simplified. But if I look at x squared minus y squared, there's no GCF. However, I do have perfect squares. This is a difference of squares. We can apply that technique where you break it down into the square roots. So x and y, and one's positive and one's negative. Remember, for our difference of squares factoring technique, it says a squared minus b squared factors into the sum of a and b and the difference of a and b, a plus b, a minus b. And so we have to be careful. This is kind of a warning problem. It's a, hey, please pay attention problem that you need to apply at sometimes multiple factoring techniques, not just one. Lastly, we have one where we have 6 terms. And some people wonder, how am I going to group these together? Well, if you just look at the problem, 5, I'm just going to look at the coefficients, 5, 4, 3, -5, -4, -3. You see a pattern. You see the first 3 numbers repeat. And so I can pair them together that way. And if I pair them together that way, if I group them that way, I look at my GCF, they all have an A in common. And if I take out my A, I'm left with 5ax plus 4by plus 3cz. If I look at my next pairing, they all have a negative b in common. And if you were to factor that out, you get 5ax minus 4by plus 4by, because the negative and a negative, to get the negative with the negative, that has to be positive, and then plus 3cz. My parentheses match, and so I can keep that parentheses, I can factor that out, 5ax plus 4by plus 3cz, and what remains on the outside is my a minus b. And so I have my final answer. I could group them together in this way and get my answer. Now I want to try something different for this problem though. In this problem, I applied the same idea. If you think about it, I broke it into two groupings. But I can also, with this problem, rearrange. I want to show you sometimes there's multiple paths to get the same answer. I mean, I see, 5, 4, 3 does repeat. But if I didn't see that, I have two 5s. And so I can actually, and sometimes you're going to have to do this, rewrite it. So I can do 5a squared and then put my 5 together with it. I could then do, I'll change colors, my 4aby and put my other 4 with it. So minus 4b squared y. I could do my plus 3acz and put my negative 3bcz there. And now for my grouping, I can use 3 groupings. GCF here is a 5ax, and inside the parentheses, you're left with a minus b. The GCF here is a 4by, and inside the parentheses, you're left with a minus b. And your GCF here is a positive 3cz. And inside the parentheses, you're left with a minus b. So if you take a look in all three new terms, they all have an a minus b in common. So you can factor that out. And on the outside, you're left with your 5ax, your 4by, and your 3cz. So there is another approach to doing this problem by factoring by grouping. You're not always going to group in sets of 2, groups of 2. You might have to look at doing groups of 3, and you might have to look at rearranging your terms to best fit the finding of a GCF.